Hey guys, so today we're going to work on lesson 22, session 2. So that would be pages 513 and 514. So let's start with our example. The total cost of renting a tent is equal to a rental fee plus a cleaning fee of $10. Write an equation with two variables that shows how to find the total cost of renting a tent based on the rental fee. You can define variables and use them to write an equation that represents the relationship between the rental fee and the total cost. So we're going to use R for rental fee in dollars and T for total cost in dollars. So the total cost is equal to the rental fee plus $10. So we'd say T equals R plus 10. So the equation T equals R plus 10 can be used to find the total cost of renting a tent. So we need to know which one is the independent variable and which one is dependent. So independent is the one that can stand alone. Okay, dependent cannot stand alone. It depends on what the other number is. So we can look up here, T, we're going to look at it, depends on what R is. And R is just its own number. It doesn't depend on T, so it is independent. So R, independent is R, and dependent is T. So the total cost depends on whatever the rental fee is. Okay, so since we add $10 to the rental fee to find the total cost depends on the rental fee. All right, number 2, the total weight of a delivery truck is equal to the weight of the empty truck plus the weight of the packages. The truck weighs 8,200 pounds when empty. Write an equation that shows how to use the total weight of the truck to find the weight of the packages. All right, so we know that the weight of packages, so the total weight of a delivery truck is equal to the weight of the empty truck. The truck weighs 8,200 pounds when empty, so that would be 8,200 plus the weight of the packages. Right, so we're going to use P for packages there. Right, and T for total. So the weight of the packages, right, so we're trying to find the weight of the packages, so P equals the total truck weight, so truck minus 8,200 for the weight when the truck is empty. You can use different variables too, so if you use that, that's fine. So we would say P equals T minus 8,200. Right, go ahead and turn the page. So we're going to look at page 514. Number 3, a scientist is studying the digging behavior of black-footed ferrets. One ferret digs 465 cubic centimeters of soil from a burrow in 5 minutes. Based on this digging rate, write an equation that can be used to predict the amount of soil. We're going to use S for soil in cubic centimeters. The ferret can dig from a burrow in M amount of minutes. Show your work. So it does give us our variables here. All right, so the ferret digs at a rate of 93 cubic centimeters per minute. Okay. All right, so we can take 465 and divide it by 5. Okay, so 465 goes inside my house. All right, can 4 go inside the house? No, but 46 can. 5 times what gives me 46? 9 times 5 is 45. I subtract and I get 1. Bring down your 5. 5 can go into 15 3 times. 3 times 5 is 15. Subtracting, you get 0. Nothing else to bring down, so you are done. So we know that the ferret digs at a rate of 93 cubic centimeters per minute. So how would we write that? 93 cubic centimeters. The amount of soil in cubic centimeters equals the unit rate times the time in minutes. So we could write S equals 93 times m. Which variable is the dependent variable in your equation? So our dependent variable, so s would depend on whatever m is. Okay, so our dependent variable is s because the amount soil he digs depends on how many minutes it digs. Right? Number 4, there are 80 calories in every 4-ounce serving for grapes. Which equation can be used to determine the number of calories? We're going to use Y for calories in X ounces of grapes. So if there are 80 calories in every 4-ounce serving of grapes, which equation can be used to determine the number of calories? So I want to know how much is in 1-ounce serving. So 80 divided by 4 would give me 20. So it's either going to be B or A. So 20 times the number of ounces equals the number of calories. So that would be A. At number 5, a family's dishwasher uses the same number of gallons of water for each load. The table shows how many gallons of water, G, the dishwasher uses for N amount of loads of dishes. What equation can be used to represent the relationship shown in the table? We have number of loads and the number of gallons used. So, can we find how many gallons for one load? Yeah, if they give us this, we can find how many for one load. So we're going to take gallons on top of our fraction, gallons per load. Right, I know that my numerator goes inside my house. Right, can 1 answer the door? No, but 18 can. 4 can go into 18. 4 times 4 is 16. Subtract, and I get 2. And I add a decimal and a 0 and bring it down. 4 can go into 25 times. 5 times 4 is 20. Subtracting at 0, nothing else to bring down. And I get 0, I am done. So I bring up my decimal, I get 4.5 gallons per load. Okay, so the dishwasher uses water at a rate of 4.5 gallons per load. The water use in gallons equals the unit rate times the number of loads. So gallons equals 4.5 times N, the number of loads. Or I could write G equals 4.5 N. I don't know why I wrote that. All right, and that's the end of pages 513 and 514.